All right, we're going to look at antiderivatives and the indefinite integral. So a function, and I'm going to call, because of these different letters here, I'm going to call that big F of x. So a function big F of x is an antiderivative of function f of x if big F prime of x is the same as f of x for all x in the domain of f. And that process of finding the antiderivative is called antidifferentiation or integration. A family of all antiderivatives is the indefinite integral of f with respect to x, and it kind of looks like this. Got a weird like S symbol there. I can just read that as the integral of f of x dx. So the integral or the antiderivative of a function, and that dx tells us with respect to what variable. Right? If big F is any function such that big F prime of x is f of x, then that integral of f of x dx is big F of x plus c. And that right there is called the general solution. And that plus c is a constant of integration, or just an arbitrary constant. You gotta think, if we're going forwards, so if I have x squared plus 2, if I do a derivative, it's going to give me 2x plus 0, right? And then we usually don't write the plus 0. So when we go backwards and we go from this function and do the antiderivative to get back here, we don't know what this constant is without any other information. So we put plus c because we don't know if there was any number there that when a derivative was taken, it just went away because it was 0. All right, so we always have to put that plus c unless we have more information that can help us find it. So, all right, let's do just a little bit of thinking before going into rules and stuff. So, let's say we have a function here. F of x is 3x squared. Can I think of 3 different functions whose derivative is this? So let's see. One function could be, we'll just do this. G of x could be, we could have x cubed plus 1, right? Because then g prime of x would give me 3x squared plus 0, right? You could do x cubed minus 1, right? Because that derivative would still give me 3x squared and plus 0, right? So really any function, let's do j of x could be x cubed and then plus c, right? Or minus c. So explain the meaning of that plus c on the function. So, okay, the only difference between these, right? So we have that same x cubed part, and then we just have the difference of a constant. So this is like the shifting. So it's whether we were going up or down, or any vertical shifting. That's what that plus c does. All right. So we can also think of things this way. We can say a derivative, right? dy dx is some function. Well, okay. If I want to put y's on one side, x's on the other, I could just multiply both sides by that dx part, right? So dy is f of x dx. And if we want to, I'm putting quotes, air quotes that you can't see, but imagine they're there, right? I want to undo that dy and that dx. Then I can do the integral of both sides, right? And then the integral of dy is just going to be y. And the integral of f of x dx is going to be whatever the antiderivative is, and then plus c, which is all right here. Right? All right, so sometimes we might have to use some tricks before integrating. And actually, I'm going to come back. This should be like a different page. I'm going to come back to this. I'm going to scroll back. So I want to look at the rules. It'll make those tricks a lot easier. So I've got both rules for derivatives and then integrals. So here they are. All right. If we have 0, then the integral is just c. If we have just a constant, then we're going to have kx and then plus c. If we have a constant times a function, we can pull the constant out and then integrate. And if we have more than one function that is just added or subtracted, we can separate the integral and add or subtract based off of what operation is there. And we have a general power rule. So when we do derivatives, right, let's say we have 3x squared. Our power rule says that we'd multiply and then subtract 1 from the power. We want to go backwards. We want to go from 6x back into that 3x squared. So let's see how we would do that. So to undo the power rule, instead of subtracting 1 from the power, I'm going to add 1 to the power. But then we have to divide by that new power. So I'm going to start with that 6x, right? So I'm going to add 1 to the power. So 1 plus 1 is 2. And then I'm going to divide by that new power. That new power is 2. So I'm going to divide by that. And I can simplify. So 3x squared. Right back to the beginning. Right? Kind of cool. All right, and then we have our exponential functions here. So just like the derivative of e to the x is e to the x, the integral of e to the x dx is also e to the x. If we have any other exponential function, right, a to the x, then our integral is going to be a to the x divided by natural log of a. And then, I just totally skipped this part here. The power rule only works as long as the exponent is not -1 because we have a rule down here for it, right? Because if I added 1 to the power, right, I get 0 and divide by 0, and I can't do that. So that power rule won't work there. And that's because the integral is natural log absolute value of x. All right, so let's go back up to these tricks here and use them. So we might want to rewrite or simplify the functions before trying anything. So I could probably rewrite that as x plus 1, x minus 1 over x plus 1 dx. And then I can cancel out my x plus 1s. So I'm left with x minus 1 dx, right? And then I can use my power rule. So add 1 to the power, divide by the new power. And really that's like x to the 0, right? So add 1 to the power and divide by the new power. So really it's just x, right? And then don't forget the plus c. All right, until we know substitution, we can't really do anything with this just yet. So we might have to multiply all of that out. So that 3x minus 1 squared is going to be, let's see, 9x squared. And then I'd have minus 3x minus 3x and plus 1. So really I've got 9x squared minus 6x plus 1 dx. And then each of these has had an operation so far. And so I could really technically separate it. And I haven't been because I've just automatically been doing it. But really that's the integral of 9x squared dx minus the integral of 6x dx plus the integral of 1 dx. So let's add 1 to the power and divide by the new power. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, and then plus c. And then we'll just simplify. So that's going to be 3x cubed minus 3x squared plus x plus c. All right, we also might want to separate out a fraction and simplify as we go. So x squared over x to the 5th is really x to the -3. And then we have 4x to the -4, and then 5x to the -5 dx. I can separate all of these out, or I can just do the integral. So let's add 1 to the power and divide by the new power. Let's add 1 to the power and divide by the new power. And add 1 to the power and divide by the new power. And then plus c. I'll clean it up just a little bit. This is just a personal preference. You wouldn't have 2 operation signs, right? And I personally also don't put the negatives in the denominator. So I would make this a -1/2. And then I also would make the exponents positive. So I would drop it down. So that would be 4/3 and then x cubed in the bottom and 5/4 with x to the 4th in the bottom as well. And then there might be cases where we have to do multiple of these tricks at once. So that x minus 3 squared is going to be x squared minus 6x plus 9. And then we're dividing it by x to the 1/2, right? So we can subtract the exponents here. So 2 minus 1/2 is 1.5. 1 minus 1/2 is just 1/2. And then we can integrate. So these are fractions. So we do a little bit of something extra here, right? We still add 1 to the power. So if I add 2 over 2, I get 5/2. But then when I divide by the new power, divided by that 5/2, we're really multiplying by 2/5, right? When you divide by fractions, you're really multiplying by the reciprocal, right? So if I add 1, that gives me 3/2, but then I'm really multiplying by 2/3. And then let's see, if I add 1, I get 1/2. And when I divide by 1/2, I'm really multiplying by 2 over 1. And I'll just simplify. So 6 over 3 reduces to 2. 2 times 2 is 4. And then 2 times 9 is 18. And then don't forget plus c. Right. And so there's the bunch of rules again. All right, so we've had where we had plus c at the end. And I said, unless we had more information, then we couldn't do anything about it. Well, here we have some more information. So this process is called solving differential equations. All right, so we can find a specific solution as long as we are given more information. So look at this. I have a derivative is 2x minus 1. And then in the original, I have f of 2 is 5. So let's solve it by doing an integral, right? You can integrate both sides. The integral of a derivative is just the original function. And then we can do the integral here. So 2x, add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And normally we would say plus c, right? Well, I have an initial condition. When x is 2, the function is 5. So let's solve it. 2 over 2 is just 1. So I have 2 squared minus 2 plus c. That's going to be 4. 4 minus 2 plus c is 2. I'll subtract 2 from both sides, so c is going to be 3. So we can say our specific solution, f of x, is x squared minus x plus 3, because we had solved for that c value. I'm going to do it again with another function, so I can integrate both sides. And I'll get f of x is 3x cubed divided by 3. And then we have, what is this, 2 over x. So really, if I separate out 2 over x dx, 2 is a multiplier, and then I have 1 over x dx, which could be natural log. So 2 natural log of absolute value x plus c. And then we know our function is 7 when our x value is 1. Say we get 1, natural log of 1 is 0, so then c is going to be 6. So my original function, or my specific solution for this scenario, is x cubed plus 2 natural log of absolute value x plus 6. All right. So here, I'm going to scroll these up. Yeah, this is going to be the last of it. Go ahead and pause the video and then try these. I'm going to go through them, but pause it, try it, and then let's see if you're right. So, all right, we'll do the integral. I get x cubed over 3 plus x squared over 2 minus 7x plus c. And I can plug in what I know. So 3 cubed over 3 plus 3 squared over 2 minus 7 times 3. 3 cubed is 27. 27 divided by 3 is 9. And then that's 9/2. And then that's 21. Let's get everything in 2's. So that'll be 2 over 2. Oops. equals 18 over 2 plus 9 over 2 and 42 over 2. And let's add these numbers. So 18 plus 9 minus 42 is going to be a negative 15. So I'll add that over, which will give me 17 over 2 is C. So our specific solution is x cubed over 3 plus x squared over 2 minus 7x plus 17 over 2. Okay, do another one here. So let's see, we have 3x cubed over 3 minus 4x squared over 2 plus 2x plus c. And we can sub in what we know. 3 over 3 is reducing to 1. 4 over 2 reduces to 2. And let's see, we get negative 1 minus 2 plus c. Let's see. Negative 1 minus 2 is what? Negative 5. So if I add 5 over to both sides, we get 1. So our specific solution is x cubed minus 2x squared plus 2x plus 1. Okay, 2 more here. I might rewrite that as t to the 1/2. So if I do the integral, I get t to the 3/2, then times 2/3 plus c. And then let's do some more math here. All right, so square root of 9 is 3. 3 cubed is 27. 27 divided by 3 is 9. 9 times 2 is 18. And that makes c negative 12. So g of t is 2/3 t to the 3/2 minus 12. And then this last one here. So we get, let's see, 2x squared over 2 plus e to the x plus c. And then if I substitute in 0, so e to 0 is 1. If I subtract 1 on both sides, I get c is 4. So my specific solution is x squared plus e to the x plus 4. And there we have it. So if you have any questions, let me know.